Okay, and here's a third example of using a Shannon decomposition on a 4-variable logic function. All right, so I went ahead and put this on the Carnot map. All right, and what I want to do this time is I want to use 2 select lines, all right, to do a Shannon decomposition for F. All right, and so here's the output F. If I have 2 select lines, I'm going to have 4 data lines. All right, so we know how that works. And in this case, I'm going to choose Y and Z. I have freedom to choose what these select lines are, but I should do it in a way that makes some sense. You know, I wouldn't want to scramble Z equal to the most significant bit and Y equal to the least significant bit. I want to keep that hierarchy in place. And I also don't want to get, you know, too crazy with the Carnot map. So typically, you would find a couple of variables together, and the way you choose that gives you different regions of the Carnot map. And typically, from there, you can just read the map. All right, so let's go through an example. All right, so in this case, I'm going to use the select lines on YZ. All right, and so if I make YZ both 0, 0, remember our steps are, once I do the select lines, I identify what region on the Carnot map that would be. If Y and Z are 0, 0, all right, this is this column of the Carnot map. All right, and so this column doesn't change for variables Y and Z. Y and Z are 0, 0, that's the definition of this column. All right, so I want to find out what should I put on line 0 to give me the function F, and it will be a function of the variables X and W, all right, because Y and Z are already fixed. All right, so I look at this, and really it's like doing a Carnot map with a stacked version, and for a 4-variable case, you can get all the adjacencies fine from it being a stack instead of a square. All right, so by that I mean, all right, if I look at this, all right, if I read that part of the Carnot map, what is that in terms of X and W? Remember, I don't need to account for Y and Z because that's already been accounted for with the selection of the column. All right, so I look at that and I read that map, and in terms of W and X, that is following W bar, right? So the line 0 should be connected to W bar. All right? Okay, so let's do more so that you can follow that. All right, so now let's move to the case where we have Y and Z being 0, 1. All right, so if Y and Z are 0, 1, we are now selecting a different column. It's this column. All right, Y and Z are now fixed, and so I want to figure out what to connect data line 1 so that I implement F. All right. And so I see some adjacencies. I know that this is adjacent to this, and I know these two are adjacent. So I can read the Carnot map, and because I'm only using 2 variables on a 4-variable map, all right, I know that I might have to have some external logic on the data lines. You know, in the previous example, we had 3 select lines on a 4-variable map, and so all we had to do was tie it to the appropriate connection between either D, you know, in that previous example, the 4th variable was D bar 0 or 1, all right? So in this case, I'm seeing some logic that I need, all right? So I have an OR, and I just read the map, all right? So if I read these 2 minterms, all right, that spans W, okay? And so if I span W, I am outside of X, all right? And so this would be X bar, all right? And then if I wanted to read this circling, all right, that is totally inside of W. So it's W or X bar. It's just like reading a Carnot map, only if it's stacked. All right, so now let's do data line 2. Data line 2 would be this column, Okay, and there's nothing that's going to be minimized here. I have to circle this 6. All right, so the external logic there is this would be an AND gate. All right, so reading this Carnot map's all I'm doing. And that would be, I'm outside of W, but inside of X. So this would be W bar X. All right, and then finally column 3. All right, so I read column 3. That would be, what's a color I haven't used? We can use gold. Column 3 for data line 3. Okay. All right, so I read this Carnot map. Here's the circling. Remember, I'm just doing within this stacked 4-variable Carnot map. These two are adjacent. All right. And so that is X bar when I read that Carnot map. All right, so there's a Shannon decomposition. In this case, we're using 2 select lines, and that's how the data lines should be connected to give you F. All right, so, I could have chosen data lines or the select lines to be W and X. If that's the case, I would have read across the rows. All right, there's other things I could do, but typically you do things that make sense to make it easier to work the problem.